Welcome to Study Loop.
Let's start this problem by writing down what we know. We know that there are indeed 5 books with missing pages. We know that in a lot of books, there's a total of 25 books. So if there are 5 that have some pages missing, that must mean that there are 20 books without missing pages. And in this particular problem, we are going to select 5 books. We're going to look for missing pages. And if he finds at least 2 books with missing pages, then the entire shipment of books is going to be returned. So since we are taking a sample size of 5 books, our N is going to be 5. Now, when we take those 5 books, we're going to take a book out of the supply. We're going to inspect it. And if we find pages that are missing or not, we're not going to put that book back into the pile before we select our next one. So when we do sampling without replacement, we are dealing with hypergeometric distributions. And again, it's when we do not replace. And if that's the case, we have a formula that we're going to follow. And the formula says P of X equals. We're going to use a combination, A items taken X at a time. We're going to multiply that by B items taken N minus X at a time. And we're going to divide by A plus B items taken N at a time. So A is going to be referencing the books with missing pages, and B is going to represent our books without the missing pages. We already defined what our N was. Our N is going to be 5. Now, in this problem, we are looking for at least 2 books. So if I translate what at least 2 books means, means that X could be 2, or 3, or 4, or 5. So let's think about what the probability distribution would look like. So if I were to generate a probability chart, when I reach into this 25 set of books and inspect a book, I might find none with missing pages, or 1, or 2, or 3, or 4, or 5. So these are the X values that we would put into this formula. Now keep in mind, we are only concerned with or interested in the probabilities of the 2, the 3, the 4, and the 5. So we are interested in the sum of these probabilities from 2 to 5. So we can use this formula 4 different times, once evaluating P of 2, once evaluating P of 3, once evaluating P of 4, and once evaluating P of 5. And if we keep in mind that anytime we are working with a probability distribution, we know that the sum of the P of X column is always going to add up to 1. So again, we could either do the 2 plus the 3 plus the 4 plus the 5, or instead, to get these values and what their total would be, I can do 1, take away the probabilities up here, and I'll be left with the total. So I could do 1, take away the probability of having no books come up with missing pages, and take away the probability of having 1 book. And I will end up with the at least 2 probability answer. So let's calculate the P of 0. Our A value was 5. The X value, in this case, is 0. We're going to multiply that by the B value, which is 20. N minus X would be 5 minus 0, or 5. And our denominator would be the A plus B, which is the total inventory of 25, and we are taking 5 at a time. So when I calculate that value out, my probability of 0 books being with missing pages would be approximately 0.29181. Now I want to also calculate the probability of 1, so I'm going to utilize that formula again. So my probability of 1 would be A, which is 5, C, my X value is 1 in this case, multiplied by my B, C. When I do N minus X, I'm doing the 5 minus the 1, so I get 4. And my denominator is going to be 25 C5. And that answer I get is going in place of this P1. So I end up with an answer value of approximately 0.455957. And when I calculate the entire problem out, when I do, this math right here, I'm going to end up with a probability of approximately 0.25223. So that's the probability of reaching into a lot of 25 books, randomly selecting 5, and coming up with at least 2 books that have missing pages.